When watching changed reality, the observer effect. A disturbing discovery. We observe the world to understand it. We measure to reveal truth. We look, assuming reality remains unchanged. But modern science uncovered a paradox. The act of observation can alter what is observed. This discovery did not merely refine measurement. It challenged the very idea of an objective universe. Part 1. The classical assumption. For centuries, science relied on a simple belief. Reality existed independently of observers. Measurement revealed properties, it did not create them. A planet's position, a particle's speed, a stone's location, were assumed to exist whether or not anyone looked. Observation was passive. Reality was fixed. This assumption shaped classical physics. Part 2. Measurement as interference. As instruments grew more precise, scientists encountered a problem. To measure something extremely small, interaction was required. Light had to strike it. Energy had to be exchanged. At large scales, this interference was negligible. At microscopic scales, it was not. Measurement began to disturb what it tried to reveal. Observation was no longer neutral. Part 3. The quantum revolution. Quantum physics formalized this problem. Particles did not have definite properties prior to measurement. They existed as probabilities. Position, momentum, and energy became uncertain until observed. Measurement did not uncover a pre-existing value. Selected one. Reality appeared to respond to observation. Part 4. The double-slit experiment. One experiment made the issue impossible to ignore. When particles passed through two slits unobserved, they behaved like waves. When observed, they behaved like particles. The only difference was measurement. Observation changed the outcome. This result has been confirmed repeatedly and remains deeply unsettling. Part 5. What observation really means. In physics, observation does not require consciousness. It requires interaction. Any process that extracts information from a system counts as a measurement. Reality is altered when information is gained. Knowledge has physical consequences. Part 6. Collapse or update. Physicists disagree on interpretation. Some argue that measurement causes a real physical change. Others argue it updates our description, not reality itself. Does the wave function collapse? Or does probability reflect incomplete knowledge? The mathematics works. The meaning remains debated. Part 7. From physics to philosophy. The observer effect forced a philosophical reckoning. Is reality independent or relational? Does the universe have definite properties without interaction? Objectivity itself became conditional. Reality appeared less like a fixed stage and more like a process involving participation. Part 8. Modern technology and observation. This is not abstract speculation. Quantum technologies depend on observer-sensitive systems, quantum computing, precision sensors, secure communication. Ignoring the observer would make these technologies impossible. Measurement is now a design consideration. Part 9. What remains unresolved. Despite a century of study, key questions persist. Does observation create reality or constrain it? Is there an observer-free description of the universe? Where does information truly reside? Science predicts outcomes with precision. It does not yet agree on what observation means. A participatory universe. The discovery that observation affects reality did not eliminate objectivity. It refined it. Reality is not arbitrary, but it is not independent of interaction. Understanding the universe now requires humility. If this documentary expanded how you think about measurement, reality, and knowledge, consider liking the video and subscribing to Interesting MindHub for future explorations. Because sometimes, understanding reality begins by questioning how we look at it.